Hello everyone. When it comes to balancing redox reaction, especially when it comes to balancing the redox reaction using the oxidation number, many students have a lot of confusion, a lot of misunderstanding, and then they think it's too difficult. How can I try to solve this using oxidation number, and do I use trial method? Do I try one by one? Won't it be time consuming to do that, and so on? Okay, I'm going to teach you a trick when it comes to balancing redox reaction using oxidation number. I think the trick is very simple. This is an update to the video that I've done in the past. Maybe some of you still confused. So probably I'll actually modify the method, and I came up with a new way to teach, and I'm going to actually share it over here. Probably this is going to be much more easier to understand. And I will start using a simple example here. Okay, here we are going to try to balance this equation, and the answers are there. Okay, so that later we can compare our answers. But here, okay, whenever you have an equation, it is very important to see, okay, what we want to do. So basically, we need to find out which one is going to be oxidized, which one is going to be reduced. So please calculate this yourself. Okay, the oxidation number of this Fe is going to be +2. This is going to be +3. So I found out that +2 to become +3, that's going to be oxidation. Okay, so the oxidation, I will write down the oxidation equation is going to be Fe2 plus. Okay, this one assuming that I do not know there is 5 over there. Yeah? So I'm going to actually try to balance the equation. So Fe2 plus to become Fe3 plus is an oxidation. So I need to find out which one is going to be reduction. So for reduction, okay, this one you can calculate yourself as well. This is supposed to be +7, and this is going to be +2. So there is going to be MnO4 is changing, okay, into Mn2 plus. Now, so what we need to do over here is, okay, you just write down, this is going to be +2, +3. This is going to be +7. This is +2. So what is happening when it comes to the oxidation and reduction? Okay, this is going to be oxidation. So the increase by 1 unit, and this is going to be decreased by 5 units. Okay, please remember this. Now, when it comes to oxidation and reduction, we need to know that in terms of electrons, okay, oil rig, you can remember this, okay, oil rig, okay, oxidation is loss of electron, reduction is gain of electron. So in this case, okay, I can say that Fe2 plus, okay, every one, okay, because there's 1 mole over there, every 1 mole of Fe2 plus has lost, okay, 1 mole of electron, okay, 1 mole of electron. And here, okay, I can notice that every 1 mole of MnO4, they have lost, okay, they have gained, reduction is gain, they have gained 5 electron. Okay, they have gained 5 electrons. So that is very important. We have to identify that. Now, the next step is, okay, we need to find the lowest common multiple between 1 and 5, okay? So because we need to eliminate the electrons, okay? So what I'm going to do, okay, the lowest common multiple is 5 actually. So this one I'm going to times by 5. This one I'm going to just times by 1 because I can cancel off, right? 5 electrons, it will cancel off. So here, if I times by 5, okay, it means this one must be times by 5. This is also 5. Okay, this is 1, so it means 1 and 1. Simple as that. So what is next? Okay, what is next? So if I have, for example, Fe2 plus MnO4 minus plus H plus to give me Fe3 plus Mn2 plus H2O. Once I get this, okay, if I want to balance this, okay, what I need to do is, I know for now, okay, since I have calculated, I know that this is going to be 5. okay, and this is going to be 5, okay, 5 and 5. And I know that this is going to be 1, this is going to be 1. So 1, and this is going to be 1. Now, how do we balance the H plus and H2O? Now, to balance this H plus and H2O, okay, this one we need to calculate, or we need to solve this, okay, which is going to be for MnO4 minus, okay, they are going to actually give you H2O, okay, and then this is going to be H plus. So this one, okay, 4, okay, I put 4, and then this is going to be 8, okay. So I know that, okay, I times by 1, so it still remains at 8, okay, because just now I times by 1, yeah. So times by 1, this one times by 1, it still remains as 4. So the one that we balanced just now was the electrons, yeah. So this one, just put the 8 here, and just put the 4 here. And without looking at the electrons now, you have actually found out the answer. So we compare the answer now. 5, 5, 1, 8, 5, 1, and 4.